Chapter 7, Day 2, we are going to first review what we worked on in Day 1. So I would like you to pause the video and try these problems, and then restart the video to find the answers and the explanations. So if you're just looking for the answers, the first one is 5x to the fourth. The second one would be c squared over d to the third. Those are the answers. Number 3, the answer is 7d to the fifth. And number 4 would be 1 over 3k squared. And the last one is h over g to the sixth. Now, if you got these right, keep going and work on today's lesson. If not, then stay here and listen to the explanation and make sure you understand what you're doing. So question number 1 is 5 times x to the negative 4, which would be 5 times 1 over x to the fourth. Again, putting a 1 under that, 1 times 5 is 5, and 1 times x to the fourth is x to the fourth. The second question, again, these are all multiplied. Remember, e to the 0 power is just 1, so we don't need to worry about that anymore. So then we end up with c to the second times 1 over d to the third. Again, putting a 1 under that, multiplying the fractions, you get c to the second over d to the third. In the next question, we have 7 over d to the negative 5. Remember, this is like writing 7 divided by 1, or 7 divided by d to the negative 5. And d to the negative 5 would be 7 divided by 1 over d to the positive 5. So now we are going to put a 1 under this and keep change flip. So now we get 7 times d to the fifth over 1. Again, multiplying your fractions, you get 7d to the fifth over 1. In the fourth example, k to the negative 2 becomes 1 over k to the second. We're dividing all that by 3. So again, you would end up with 1 over k to the second divided by 3. So with keep change switch, or flip, this becomes 1 times, and then 3 over 1 becomes 1 over 3. And so now when we multiply, we get 1 over 3k to the second. And the last question here, you get g to the negative 6, which is 1 over g to the 6, all divided by 1 over h to the first. Again, dividing with fractions is keep change flip. So this becomes 1 over g to the 6 times h to the first over 1, or just h, which becomes h over g to the 6th. So hopefully you're starting to get the hang of these negative and zero exponents. Today, and we are going to work on some other properties of powers, but let's just remember that we kind of reviewed this and it came up in the warm-up, but basically at this point now, we can say if n is a positive integer, then 1 over a to the negative n becomes a to the positive n. So basically, anytime you have a negative exponent, it flips up to the top of the fraction if it's on the bottom, and if it's on the top, like k to the negative 3, that flips to the bottom and becomes 1 over k to the third. Okay, so that's sort of a little bit of like the shortcut of all of this. And as you start to work these out the long way, like I've just been doing, you'll start to see the pattern, hopefully. Okay, so today we're going to simplify an expression using the product of powers rule, and we're going to kind of use a discovery approach on this. So first of all, we're going to define what a monomial is, and eventually in this chapter we'll get into what a binomial and trinomial are and so forth. So a monomial right here is a number, a variable, or a combination of numbers and variables multiplied together. So the key is a monomial is one term. So some examples of monomials would be like 2 x to the third, because that is a combination of a number and a variable multiplied together. Or another example would be just a simple negative 1/3. That is a single number. So it can be a number or a variable or a combination of numbers and variables multiplied together. Or it could get more complicated, like x, y to the third over 4. So those are all examples of monomials. So here's how to multiply x to the fourth by x to the third. Well, we know x to the fourth is x multiplied 4 times. So x times x times x times x. And we know x to the third is x multiplied 3 times. So if we write it out the long way, x to the fourth is x times x times x times x, and x to the third is x times x times x. So how many x's do we have multiplied all together? We have x to the 7th. So look at the next example. X to the third times x to the 5th. Again, we have x to the third is 3x's multiplied together. X to the 5th is 5x's multiplied together. And when you multiply all of them together, you get x to the 8th power. So can you see what's going on here? Can you see a pattern? That's what we're kind of looking for. So now try some using this method, okay? I want you to try to write these out the long way, okay? So what I mean is write x to the second as x times x. Write x to the fourth as x times x times x times x. Then write the answer, and how many x's are being multiplied together? 6. So now you try it for these last 3 questions. Pause the video and then restart the video to see if you got it correct. The next one would be x to the 6th, because you'd be taking 5 x's right here and multiplying it by 1 more. The next question would be equal to x to the 9th, because again, you're multiplying 7 x's by 2 more. And you get 9 x's multiplied all together. And last but not least, this would become x to the 7th, because again, 4 x's multiplied with 3 more. And so you get a combination of 7 x's. So again, do you see a pattern? Do you see a shortcut about what's going on? Hopefully, you're starting to notice here that when you take 2 and you 4 and you add them together, you get 6. This is 7 x's multiplied with 2 more gives you a total of 9 x's. And here's 4 x's and 3 more makes 7. And that's what's really going on here. Now in the 5, you have understood kind of 1 right here, and that's why it is, don't forget, 5 plus 1 or 6 altogether. So, do you see a shortcut now? Hopefully you do. Hopefully you start to see that this is really x to the 15 plus 10 power. You're adding these powers, 15 and 10, together. And that gives you the total answer of x to the 25. What about the next one? You try it. See if you can get this one correct. This would be x to the 38. So what is the general rule? The general rule is if you have x raised to the a power times x times x raised to the b power, then what you have is you have x to the a plus b power. And that is our general rule for multiplying powers with that has the same base. So one of the keys to remember is that the x, okay, is the same variable. And the same variable is being raised to the power. So you are multiplying x a times, and then you're multiplying x b times for a total of x multiplied a plus b times. Okay, well, what if you have more complicated ones? Let's take a look at a few more complicated ones. Use the commutative and associative properties to get the like parts together and then multiply. So here are some examples. Notice all of these again are just multiplied together. So you have the 3 and the 2 right here. Those are just multiplied together and I put them next to each other. Okay, then we're putting other like things together, like x squared and x to the fourth. So I just put them next to each other so it's a little bit easier to see what's going on. And then finally, we have y and y to the seventh. Oh, that's not a very good color. Let's try again. Let's try yellow. Y and y to the seventh. And again, those next to each other right there. Oh, that's not a highlighter. Sorry. Wrong button. So here is where the y's come from. And so now if we multiply all the like things together, what we end up with here is we have 3 times 2, which is 6. We have x to the second times x to the fourth is x to the sixth right here. And then we take a look at our y to the first and y to the seventh, which gives us y to the eighth for our answer. So basically, you could rewrite everything with the like parts together, and you can see the next example is shown. But sometimes what you can do rather than write them together is just kind of underline or highlight the things that you're going to multiply together. So plain old numbers get multiplied with plain old numbers to give you the plain old number of -20. So -2 times 10 is -20. Okay, then let's look at for x's to be multiplied together. We have an x here, and we have 8 more here, so we have a total of 9 altogether. All right, now we go on and we have a y to the fourth, and we have a y to the second, so that gives us y to the sixth. And this plain old y to the w to the fifth doesn't have anything else to multiply with it, so that just stays the same. So now you try some. Okay, you try the next 5 right now. Pause the video, and when you restart the video, I'll have all the correct answers on the video. And then after that, if you still need some more help, then you can listen to the explanation that I'm giving as I go through this. So try these 5, and if you get them correct, then I think you're ready to move on to the homework. And if not, if it's incorrect, go back and review the slides and listen to my explanations. So as you finish, check your answers. If it seems like, oh, I found my mistake, I have one small mistake, great, move on to the homework. If you're making quite a few mistakes when you're checking these answers, then I would stop and either review the slides or listen to the explanations before you move on to the homework. So here are all the answers. Take a look. Move on or continue listening to the video for the explanations of these problems. Okay, on this number 1, I have to multiply the 2 and the 10, and that gives me my 20. Then I'm going to multiply the x squared and the x to the 8th together, and that is going to be 10 x's all together being multiplied. And then last but not least, I have 1y multiplied with 2 more, which gives me 3 y's all together. And sometimes students get a little messed up because they forget this is like y to the first, so you have to add the 1 with the 2 to get the y to the third. Okay, next example right here. We have the 5, whoops, meant to use a highlighter. We have the 5 multiplied with no other numbers, so it's just 5. Then we have a multiplied with a squared. That gives us a total of a to the third. And then last but not least, we would multiply the b and the b together to get b squared. Again, if you start to see your mistakes, see if you can fix them right now. Stop the video, see if you can try these other three, get them correct, then restart the video and make sure you have them. And if not, continue to listen when you restart the video. Okay, in question number 3, we multiply the 2 and the 4 together to get 8. And then we multiply the x squared with the x squared with, I better blow this up, with x squared, which gives us x to the 4th. And it looks like I have a simple mistake here, that this should also be a y with that as well, because now I have this y being multiplied on its own. So, apologize for that. It happens. There we go. All right, moving on to number 4. Okay, again, here's the explanations if you're not getting these correct. We have 5 multiplied with -2 gives you -10. You have x squared, and there's no more x squareds to multiply with it, so that just stays the same. And then you have y multiplied with y squared would give you a total of 3 y's multiplied together. And the last question here, what we have is we have 8 multiplied with -4, that gives us -32. Then we have a squared. We have a squared, and a gives us a to the 3rd power. And finally, we have b to the 5th times b to the 2nd for a total of 7 b's all multiplied together. So this is the end of the day 2 lesson